Okay, input and output resistances of a bipolar transistor. What is the input resistance and output resistance from collector or from emitter? So, how do we do the input and output resistances? For the input resistance, you connect the voltage source and look at the current from there, but you keep the output an open circuit. That means you remove the load. When you look at the output resistance, you short the input. So first look at the input resistance. So this is our small signal model. We're going to put the voltage source here, and we call it Vx, and look at the current from here, and we will find our Vx over Ix. Well, in this configuration, this circuit basically is just like this. Nothing is in the other part is adding to us, because this is collector current, base current, and they add to the emitter current, and this has nothing to do with this one. So it's basically just the R pi. That's your input resistance. So when we look at the output resistance from the collector, what we're gonna do, we need to short the input, and put a voltage source here, and look at the current. So we short the current voltage here. That means we made the V pi, this voltage, 0. That makes Gm V pi 0. That means there is no current going on this direction. That doesn't mean that it's short. It's just there's no current. It's actually open. So it turns out the circuit to be just like this. So your output resistances in this case is your little RO. Now the more complicated one. What happens if you look at the output resistance from the emitter? Now you're gonna do the same thing. We're gonna short the input. So if you're looking from the emitter, we will actually short the collector as well, because we're looking at from here, Vx and Ix. So there is a current going on here, there's a current coming on here, and there is a current, we'll define it this direction. So if you look at here, R pi and RO are actually in parallel. They're connected here, same, and they're both grounded. So though wherever I have R pi, it's actually R pi in parallel with RO. So Gm times V pi, that's your current from here, plus Ix is equal to, because it's negative V pi divided by the resistance between V pi. This is V pi, this is also V pi. Same nodes. Because this is grounded, so this is going to be R pi in parallel with RO. If you see Vx here, this is V pi, so V pi and Vx are the same with that opposite sign. So from here, if you write Vx over Ix, it turns out to be 1 over R pi in parallel with RO plus Gm. Or your output resistance here can be also written 1 over Gm in parallel with R pi in parallel with RO. We talked about 1 over Gm being very smaller than R pi and RO, so this resistance is going to be approximated as 1 over Gm.